Hey guys, we are working on algebra, big ideas, and we're doing chapter 3, section 3. We're going to talk about linear functions, okay? So let's just get going. Stop it, pause it whenever you need to catch up. Change your captions so it's in the language that you need to use. Okay, let's start out. A linear equation in two variables. The variables that we typically use are x and y, is an equation that can be written in the form y equals mx plus b. Okay, that you should remember from middle school. Y equals mx plus b. An example can be y equals 2x minus 3. It could be y equals 1/2 x plus 16. Okay, this equation is in the form y equals mx plus b. The m and the b are numbers. They don't change. They're just numbers, which we call constants. Y equals mx plus b. This is my m. 1/2 would be my m. 16 would be my b. We're going to practice that later. So where m and b are constants, they are not variables like your x and y. There will always be a number filled in. A number, it doesn't change, okay? The graph of a linear equation, if you look at the word linear, it has the word line in it. So whenever we graph one of these equations, when we graph a linear equation, it will always be a line. Something to notice before we continue. In our previous work, we were always, in the past, we were solving equations that were in the terms of one variable. That's all we were doing, is solving for one variable all the time. Pretty much everything we did, there was one exception, but most, 90% of what we did was solving for one variable. In this chapter, we have been working with two variables. We are working with y and an x. We have two variables. Go back to this one. When we had one variable and we were going to graph the answer, we only drew one number line. And on the one number line, we would plot our answers. If it was an inequality, we might shade our answers. But we only did it on a one-dimensional number line. Now that we have x's and y's, this is two-dimensional, and we're going to do it on what's called the coordinate plane. So now we're going to two dimensions. We have two axes. We have two variables. Okay, so that's this chapter. Okay, let's go back to this. A linear function. So you guys got to remember, a function means no repeat x. Right? You're never going to repeat your x. Every x has its own y, one unique y, and the vertical line test. If you have a function, you could take a vertical line and move it through the function, and it's never going to hit more than 1 point. So if I took this and just kept moving through it, I only hit 1 point. Function, yes. This one, yep, it's a function. I'm going to flip my paper over. That's not a good one. Let me bring another sheet here. Sorry, guys. If I do this, I draw this this is not a function, right? Not a function. If I do a vertical line, I'm going to intersect 2 points. Not a function, okay? If I draw a line, I could look on this line, vertical line test, I only intersect 1 point. If I draw a horizontal line, I only intersect 1 point, okay? But there is one line that is not a function. If I draw a vertical line, and then I do the vertical line test, a vertical line is not a function, okay? Because it would intersect an infinite number of points, which is more than 1 point. So go back to this. A linear function, okay? I'll go right here. A linear function is a function whose graph is a non-vertical line. Linear equation, line. But when we talk about the special function, it's a non-vertical line. This isn't a real big deal, okay? Big deal, big deal. This, yeah, it's okay, not real super important. Okay, this is a big deal here. When we're talking about this y equals mx plus b, this m is our slope. Most of you guys know that. It's also called our constant rate of change. This is our rate of change. So a linear function has a constant rate of change. Okay? Constant means does not change. That's what constant means, does not change. In class, we're going to do this. You all may not understand it, but this is what we're going to do in class. I'll show you real quick. Okay? I'm going to do, this is time on this axis. I'm doing it sloppy. It's not going to be pretty. And up here, we'll do speed. Okay? I'm going to leave my house, and I'm going to drive 10, 20, 30 miles an hour. So I'm going to pull out of the garage, okay? And then I start driving 30 miles an hour. And I'm going to go for, I don't know, 10 minutes. And then I get to a stop sign, and I have to stop. When I stop, I'm at 0. My speed is at 0, right? I speed up. I'm at 30 miles an hour. I go constant 30 for a while. Then I slow down. Probably wouldn't slow down like that. I'd probably slow down like this, right? Slow down. That's still a pretty hard break. I stay stopped at the stop sign. Then I speed up, and I'm going to go 50 miles an hour. I'm going down Route 2, and I'm going to drive to South Bend, okay? This, I'm driving, I'm speeding up, okay? I level out my 30, I slow down, I stop, I speed up, I level out. This is not a constant rate of change, right? This is not, my slope is my rate of change. This is all over the place. This is not constant. Okay, now I'm going to go to another example. Let's say I got a tree. You guys, I am making this up. I have no idea if this is true. I'm making it up. We're going to say this tree grows 2 inches each year. Okay? I'm going to buy this little tree when he's a little guy, and I'm going to plant him in my yard. He's only going to be a foot tall, and I'm going to start growing. And he's going to grow 2 inches in 1 year. Then he's going to go up 2 inches in 1 year. And then he's going to go up 2 inches in 1 year. And he's going to go up 2 inches in 1 year. And this guy keeps growing forever at a rate of 2 inches a year. Okay? So this 2 inches every 1 year is a constant rate of change. It has a constant slope. It doesn't change. Okay? That's what rate of change is showing you in a graph. This one is constant, stays the same. This one is not the same. Okay, let's go back. Okay, a non-linear function does not have a constant rate of change, so its graph is not a line. Okay, that is all the words. Now we just got to practice. So let's practice a little bit and see what we got, okay? Here. Does a graph represent, and you guys stop whenever you need to stop. Stop and think. Don't just let me talk to you. You stop after I read it, you turn it off, you answer it, and then check your work. Does a graph represent linear or nonlinear function? Line or not a line? Line or not line? This does not have a constant rate of change, not a line. It's not a line. Okay. This one, does it look like a line? Yeah, looks like a line. This one is a linear function. It's also a function if I do the vertical line test. Okay, and it has a constant rate of change. Okay? Now on this one, I'm going to go from a chart. What this is representing is ordered pairs. That's all it represents. This is my x and my y. This is representing ordered pairs. It's representing the ordered pair 336, sorry. The ordered pair, remember ordered pair always goes x then y, 6 then 30, 9 then 24, 12, and then 18. Okay? I'm going to show you how to answer the question. Does this represent a linear or nonlinear function? One option to B would be to graph this. Because I know what the answer is, I'm going to do this sloppy. You would not want to answer the question using this strategy or this method, but it gives you a concept of what's going on. I'm going to plot the point 336. It's going to be way up here. And then 630, I'm going to say is about here. 924 about here. And then 1218. Because I know what's going on, I know this is a line. But we don't know that for sure. This is a rough graph, and I'm just giving you the idea. So to find my rate of change, I'm going to find out how much does my x value change. 6 minus 3 is 3. So if I add 3, I'm going to get 6. 9 minus 6 is 3. So if I add 3, I'm going to go 6, 7, 8, 9. Here also, add 3. So on each of these, I'm adding 3. Okay? Down here, 36 to 30, I am subtracting 6. Subtracting 6. Subtracting 6. Okay. Here's where you have to listen. For every 3, I'm going up on x. On y, I'm going down 6. 3 up on x, down 6. 3 up on x, down 6. They are changing the same together. It is exactly the same. 3 goes to negative 6, 3 goes to negative 6, 3 goes to negative 6. Yes, the rate of change is constant. this is linear. Okay? Now let's go to this one. 3.5 minus 1, right? So my calculator, if you can't do it, we'll do it real quick. You should be able to do it, but 3.5 minus 1 is 2.5. Okay? 6 minus 3.5, 2.5. So these are all jumped. The interval is the same. 2 to 9. 9 minus 2 is 7. You guys can subtract. 20 minus 9 is 11. 35 minus 20 is 15. So when I look at this, this is going up 2.5, and this is going up 7. This is going up 2.5 again, but now it's going up 11. This is going up 2.5, but now it's going up 15. No, the rate of change is not constant. This is a well, is it a function? Yes, because there's no repeat x's. So we also should check that. But this is a non-linear function. Okay? I'm going to do a little bit on the back. And then I'm going to stop. I'm going to do the other video later. Okay. Now, identifying if it's a linear function using equations. Okay? We said if it's equation, if it's linear, it can always be written in the form y equals mx plus b. Okay? Things to notice on this. Y equals 2/3 x plus b. Okay? Oh, let's say plus 8. Okay, plus 8. That is an example. What I want you to see on this is that the exponent, even though it's not written, this means y to the first power. This means x to the first. Okay? If you have any exponent here other than the 1, like if you have x squared or x to the negative 1 or x to the 1/2, it is not linear and it changes the shape. Okay? So can we write it in this form? And if we can, it is called linear. Right away, this one, let's get rid of it. I've got a y squared. I can never have an exponent of x or y that's not a 1. So this is non-linear. Okay? No, that one's not good. This one here, see how it says 3 up to the x power? This one, nope, non-linear. Y equals the square root of x. You guys aren't going to remember this, but that means y equals x to the 1/2. Okay? This is non-linear. I don't think I have to put the dash in there, the hyphen. Okay? This one says 2 with x in the denominator. Nope, can't do it. You cannot have x in the denominator. This is non-linear. Okay? X always has to be in the numerator. The exponent is 1. If you did this is a long time ago for you. If you did this in middle school, not sure. This would be x to the negative 1. That's what makes it in the denominator. Now let's look at this one. I've got y to the first power, x to the first power. Looks good. Could I write it like that? Yep. This is y equals mx plus b. Ooh. Ooh, yes. Finally, our first one. This is linear function. Okay? This one here is harder. I don't have an x here, but I do have a y. This one is linear as well. And I'll show you what the graph looks like. Okay? This is saying my y value is always 3.8. The y is my y, that's my up, down, right? That's my highs and lows. It's how far up and how far down I go. Y is 3.8 high all the time. So 1, 2, 3, 4, 3.8 high. And that is a line. If you thought about this, y equals mx plus b, I could say y equals 0 times x plus 3.8. So it can be written in this form, and your slope would be 0 because the slope is 0. A horizontal line has a slope of 0. Okay, and then the last thing, you guys, I'm going to talk about this in the next video, but right here, you guys try these, see if you can do these, or just like the front, and this here, is this linear, yes or no? Linear, yes or no? Linear, yes or no? So you can finish that up, and that takes care of half of this packet, and I'll do the second half in another video. Here you go, guys. Hope it helps.